Good day, everybody. Once again, we are back together. Welcome to our YouTube channel where we are looking at maths and science. Okay, so if you haven't subscribed, please just make sure that you're part of the channel. Be a part of the family. Welcome, welcome, welcome. And just hit that subscribe button. Do it now, okay? And for those of you who need assistance with mathematics or physical science, of course, you're more than welcome to get in touch with us. And our email address is info@mlungisinkosi.co.za. Right, so today we are still looking at trig functions. So in this case, we've already covered the sine function, so we want to look at the cos and the tan. What I'm going to do is that I'm going to try and compress all of it in one video, because you now know about the vertical shift, the horizontal shift, and the amplitude and all of that. Okay, right, so let's get into our very first one. So now let's talk about the cos graph. So the normal cos graph, okay, y is equals to the cos of theta. So usually what it looks like is that I'm going to draw it between the period of 300 minus 360 to 360. Okay, so this is what a normal cos graph would look like. And when I say normal, I just simply mean that, with an amplitude of 1 and also a frequency of 1 as well. Okay, so we know what amplitude is and what frequency is. In this case, what it would look like is it would look like the following. So I'm going to have 90, I'm going to have 180, 270 and 360, and of course I'm going to do the same on this side. Minus 90, minus 180, minus 270, and let me just try to extend this a little, and this is going to be minus 360. So what the cos graph would look like is that unlike the sine graph that starts at 0, the cos graph starts at 1. That's if the amplitude is 1. Okay, so at 90, the cos graph is 0. At 180, the cos graph is negative 1. At 270, it becomes 0. And 360, it becomes 1. So in this case, we end up with a graph. Okay, I'm going to try to jot to connect those points. Yeah, you have a graph that looks like this. Now, the thing about the cos graph is that it also becomes a mirror image of itself around the y-axis, right? So in this case, it would do the same on this side, okay? So, yeah, I'm sure you get the point. All right, I know my drawing just looks a bit jittery, but I'm sure you get the point. Right, so in this case, this is what your normal cos graph would look like, okay? So now what we're simply going to do is we're going to look at the shift of the graph. Okay, just remember, we said when we're looking at frequency, okay, remember that, affects the period of the graph, but of course, we're going to look at a couple of examples. Now, just quickly to talk about the domain on this graph. Remember, the domain is where the graph exists in the x-axis. So the domain in this graph would be x is an element of, in this particular one, I've taken it from minus 360 to 360. But then what is the range of this graph? So y would be an element of minus 1 to 1. So that would be the range. It starts from minus 1, okay, and its maximum amplitude would be at 1. So in this case, it's from minus 1 to 1. Okay, so right, so what I want us to quickly look at is what would the graph look like when we are changing different things, and then obviously we're going to look at the tan graph thereafter. Let's take our first example. All right, now let's have a look at the first graph that we have. So I'm going to draw the graph of y is equals to cos of 2x. All right, so what have we done here? And by the way, we are taking it within the restrictions. X is an element of 90 and 180. So what have we done here? We've changed the frequency of our graph. Okay, so remember what the frequency stands for. It means that within a normal period of 360, I'd be able to squeeze in two graphs, okay? So in this case, what would my graph look like? It means, remember, when the amplitude is 2 in this case, all right, I've just, not amplitude, rather the frequency. So when the frequency is 2, what it means is that my period, now I want you to please listen carefully. So what would be my period? My period would be 360 divided by the frequency. So the period in this particular case would be 180. Now please note, because the period is 180, it means that I would be able to draw a full cos wave within a period of 180. So what that means is that now I've compressed the graph, okay? So which means within 360, I would be able to actually draw 2 of them, okay? So I hope that makes sense. It means that we've increased the frequency of the graph. So now, normally, I would say, okay, I take 90, 180, and so on. But in this case, because I want to squeeze a full graph within a 180 period, so I'm going to take half of every one of my angles. So in this case, I'm going to say instead of 90, I'll take 90 divided by 2, which is 45. Instead of 180, I'll say 180 divided by 2, which is 90. Okay. And instead of 270, I'll take that divided by 2, which would be 135. And that would be 180. Of course, you'd continue there. And so on and so forth. My restriction is up until 180, so I'm going to keep it to that. I'll do the same on this side, so that would be minus 45, okay, and that would be minus 90, okay, and my graph would continue like that. Okay, let me draw it in a different color. All right, my amplitude is still 1, okay, so I know that my amplitude would be 1. So what the graph would normally do at 90, okay, let's start at 0. What's the cos of 2 times 0? That would still be 1. Okay, let me draw that in red. So that would be 0. And what would be the cos of 90 usually? Cos of 90 is 0, but 2 times 45 is actually 90. So that's why at cos of 45, this time you'd have 1. Okay, so remember, I'm doing exactly what the cos graph would do. At 90, you'd see that we'd have a value of minus 1. Okay, so there's a minus 1 there. I would have a 0 there, and I would have a 1 there. So do you see this looks like the normal cos graph? So always have it at the back of your mind what the cos graph looks like. Okay. I find it quite helpful, you know, for you to actually have a picture of what your cos graph would look like. And of course, we did say that it is a mirror image of itself, in this case, around the y-axis. So in this case, I know this is x and that is y over there. And yeah, that should have cut there at 45. Sorry about that, but you get the point. And so that is what our graph would look like. Okay, now of course, once again, what would be our the amplitude of this graph? It would be 1. What would be the domain? Of course, we said the domain, we always get it from the restriction there, but the range in this case, once again, our range is between 1 and minus 1. Okay, so y would be an element of minus 1 to 1, and that is what our graph would look like. Okay, right, so hopefully that makes sense. Right, so we're going to look at just quickly another graph. So what I'm going to do, I am going to actually include a vertical shift this time around, okay, so that you can see how that affects everything else. Of course, I think from here on, we'll just quickly skip to the 10 graph so that we just compress everything into one lesson. Okay, let's go. All right, looking at the next question. So we are drawing the graph of y is equals to cos of 3x minus 1. And again, we are taking that between the the restrictions of minus 90 and 180. So what we want to do is now, there are two things that we've changed here. We have changed the frequency, and we have also shifted our graph vertically. Okay, so we have taken it -1 or 1 unit down. Okay, so let's see what that graph would look like. Of course, what you can do is you can draw your table to see what that graph would look like. I always maintain, just remember what the normal cos graph looks like. Now in this case, what I'm going to have is that my frequency is 3. So what that means for the period is that it means that you can squeeze in a normal cos graph. Okay, that would be within a 360 period. You can squeeze in 3 of them. So in this case, what would be my period? My period would be 360 divided by 3, and that would be 120. So that means for your normal points, 90, 180, 270, and 360, you need to take those and divide them by 3. Okay, so I want you to think about it. So under normal circumstances, we'd have 90, 180, we'd have 270, and we'd have 360. Now you would take those points and actually divide them by 3 to complete a full sine wave, right? Okay, so let's take the first one. So we'd say 90 divided by 3, that would be 30. Okay, and you'd say 180 divided by 3, okay, and that would be 60. Okay, and you'd say 270 divided by 3, that would give you 90. Okay, and obviously 360 divided by 3, that would be 120. Okay, we just need to extend this a little. Okay, so it keeps now with increments of 30 degrees. So I'd have minus 30 this side, minus 60, minus 90, okay, on the side. Okay, so that is where I would have my normal cos graph, right? Now, let me just draw what it would look like normally before we have the vertical shift. Okay, so I know at 0, my cos graph would normally be 1. Okay, I know at 90, it would be 0. I know at 180, it would be minus 1. I know at 270, I'd have another 0. And I know at 360, I'd have another 1. So this is what it would look like. Okay, so in this case, I'd have, my goodness, I should have actually just extended this a little bit more, but I'm sure you'll get the point. So I'll have 150 over here, and I will have 180 somewhere, in the unseen or the unknown. Okay, so it would repeat there. So at minus 180, of course, it would be somewhere there. All right, so in this case, this is what my cos graph would look like under normal circumstances. All right, but remember, what have I done now? Where this should have been minus 1 and this 1, I would take this very same graph, and now I have to shift it downwards. Okay, I have to shift it by 1 unit down. Okay, so in this case, where it was supposed to be 1, 1 minus 1 would be 0. So I'd do that in the yellow or the mustard. Okay, in this case, there's my graph. Where it's 0, it's going to be minus 1. Where it's minus 1, it's going to be minus 2. And where it is 0 again, I'd have minus 1. And where it is 1, it would be 0. It's 0, it's minus 1. I'm sure you get the point, right? Again, minus 30, I'd have the graph at 0, but now minus 1. Okay, so at 60, minus 60, I'd have it at minus 1. So now it would be at minus 2. Can you see? What we've done is that we've taken this graph and we have shifted it downwards. And at 90, we have 0, but now it would be minus 1. So all we simply do Just connect those dots. Okay, try my absolute best here. And essentially that is what our graph would look like. All right, so the actual answer is the yellow graph. Okay, so that is what our graph would look like. Ladies and gents, I am hoping that obviously you are getting the gist of what we're trying to do. So what we'll do is later on, we'll just not in this session, we will look at past exam questions that are involving graphs, especially when they draw them on the same set of axes and they ask us different questions. Those get quite interesting. But the point is, please just know what it would look like. And this is, by the way, relevant for even grade 11s as well. Okay, so it would really be beneficial when they are able to draw these graphs. Okay, right. So once again, now let's talk about the domain in this case. Right, we did say that domain is where the graph exists in the x. Okay, so in this case, we know that it would be from minus 90 to 180. But what would be the range now? Okay, let's talk about the range of this graph. Okay, we know its amplitude would be, again, I want you to note, its amplitude is 1. So meaning that, its highest point, or rather its amplitude. So this would kind of be the reference point. So it's 1 up and 1 down. So its amplitude is still 1. You can see there the value of A is still 1 there. Okay. So, but now the range, let's talk about the range. You see this graph is from minus 2 and its maximum y is 0. So my range would be y is an element of -2 right up until 0, and that is where your range would be. All right, so I hope that makes sense. I want to just quickly, ladies and gents, maybe just talk about the Tan graph. It's one of the weirdest graphs that you'll get. But yeah, they don't really play around a lot with it, but I'm sure you understand now what we mean by frequency and so on and so forth. Okay, right, let's do that quickly. All right, now let's talk about the Tan graph. So the Tan graph is really pretty much the strangest graph of the bunch. Okay, so first of all, I'm just going to take the normal Tan graph, okay, where the amplitude is 1, where the frequency is 1, and just look at it. Let's draw that graph within the period of 360 minus 360. Okay, so let's say x is between minus 360 and 360. All right, now let's have a look at it quickly. What would that graph look like? Okay, right, so as I said to you, it always helps for you to know what the normal graph looks like, so that you can be able to accommodate the shift. Of course, usually at school they teach you how to draw that table. I find it quite cumbersome, and it wastes time. It's better when you know what the normal graph looks like, and thereafter you can just simply adapt what you need to. Okay, right, so the normal graph, so in this case I'm going to start at 90. We'd have 180, we'd have 270, and we'd have 360. In the x, of course, that's minus 90, minus 180, minus 270, and minus 360 in the y. And in that case, what I would normally do, okay, now you need to keep this in mind, at sort of the odd values, okay, the Tan graph would have what we call asymptotes. Okay, so at 90 and 270, I'd have my asymptotes there. But the same thing for minus 90 and minus 270 there. Right, so what the normal Tan graph would look like. Okay, so it starts at 0. Okay, and what it does is it does something like this. Okay, so I'm trying to show that it actually doesn't touch that asymptote there. okay, and it does the same on this side, okay, so it never touches. In this case from 0, so the 10 of 45 is usually 1, okay, not usually, well, it is 1. So 10 of minus 45, that would be minus 1 as well. Just keep that in mind. Okay, and what it does is that at 180, you kind of, you remember when we said that the 10 graph repeats at every 180-degree cycle? Okay, so you kind of have that upward, downward, so it repeats at 180. Can you see? So you had it going up initially from 0 to 90, and then going down thereafter. Okay, and at 180 again it goes up, and then from 360 to 270 it goes down. So it just keeps repeating like that. Okay, another up and down over here, and of course from 360 it would go up like that. Now this is what the normal 10 graph looks like. You gotta admit it does look kind of strange and weird, right? But in this case, just keep in mind this is your 10 graph. Okay, so what we're going to look at is, where does the graph exist? What would be the, you know, obviously when they've given us, in this case, our domain in this particular graph. Remember that even if I were to give a domain, say for argument's sake, I was saying, okay, where does the graph exist in the x? It would be x is an element of minus 360 to 360. But now, please keep in mind that x cannot be equal to, now in this case, it does not exist at x is equal to 90, okay? It does not exist at 270. In fact, let me say plus or minus. Okay, so I'm trying to write 270 there. So at plus minus 90 and at plus minus 270 for this particular restriction. Okay, so in that case, it does not exist. And what about our range? Our range, where does our graph exist? In this case, it's from minus infinity to infinity, right? So you just simply say y is an element of real numbers. Okay, so that would exist for all values from infinity to infinity, because it goes all the way up and all the way down, and it exists for all those values. Okay, right, so I hope that makes sense. Right, so what we're going to do is, let's just quickly take a graph. Let's say y is equal to, okay, let's just change. And by the way, what I've noticed for the exam is that they don't really change much when it comes to the 10 graph, of course, because it already just looks as weird as it does. Okay, but of course we always need to be mindful, you know, of those changes. So let's say, what happens if I say this is y is equals to 210, let's say, yeah, let's say 210x, yeah, let's say plus 1. Okay, so in that case, let's try to draw the graph of y is equals to 210x plus 1. Okay, let's draw this for x is an element of, let's say 0 to 360. Let's not complicate our lives, right? So all I'm simply going to do, once again, I know in this case that my amplitude is 2, right? But for the 10 graph, you only need to worry about the amplitude when it comes to the values of 45. Okay, so let's have 90. Let's have 180. Let's have 270 and 360. Right, now because they did not change the frequency of my graph, still a normal frequency, and we don't have a horizontal shift. So in this case, I didn't shift it horizontally. It means that my asymptotes would still be at the same points, that is at 90 and 270, right? Now, I know my 10 graph always starts at, now, please, I want you to note, in this case, the 10 of 0 is 0. So 2, 10, 0, that would give us 0 plus 1. So it means that now, instead of our graph starting at 0, it now would start at 1. So 10 of 0 would be 1. Okay. And then, of course, in this case, we know that the 10 of 90, that's undefined. Okay. So in that particular case, let's take 10 of 45, because we know at 45, 10 of 45 would be 1 under normal circumstances, right? So now you'll say 10 of 45, so that's 2 times 1, which is 2, right? Plus 1, so which means at 45, it would not just be 1, but it would be actually at 3. All right, so if that's 1, 2, okay, 3 is somewhere there. Okay, so I wouldn't be able to fit this graph as nicely as I would like to. Okay, but nonetheless, we'll still do our best within what is possible. Right, so there's 3 somewhere there. So let's say this is x is equal to 3. Okay, right, so at 90, definitely undefined. Now, at 180, we know that our graph would be 0. So 210 of 180 would be 0, plus 1 in this case. So it means that our graph would be at 1. Okay, and maybe let me do one for 125. Okay, let's take one for 125, somewhere there. Okay, since we know that would have been minus 1 as well, right? So if I say 210 of 125, I'm going to put that in my calculator. Okay, so that's 125, and I'd say plus 1. You see, okay, so I get well, I've got a strange value there. Okay, nonetheless, let's do this. So I've got at 180, I know that my graph is 1 again, because we've added 1. And then at 270, that would be undefined. What's between 180 and 270? I think that's 225, right? So at that 225 value, again, I would have a 3 somewhere there. Okay. So where would it cross 0? Okay, so in this case, right, let's try and draw that graph. Yeah, maybe I should have made 3 there. Okay, so those are my asymptotes. Sorry that I'm, see now, let's rather make that point there. Okay, so my point, okay, there's my graph there. And something like this. Okay, so there's my graph there, and this one here does the same. Okay, so I'll have to just change that asymptote there, sorry, that 45. Of course, because I'm drawing an inaccurate graph and not drawn to scale, my values would tend to deviate just a bit. Okay, so in this case, at 360, I know that I'd have a 0, but this time around it's 0 plus 1, so I would have that there. And once again, my graph would cross to that extent. Okay, right. Now, suppose they asked us about these values here. Okay, and I want to show you where, what we've been doing comes in. They want to find out what are these values where this graph becomes 0. So you can take your equation. We said that's 210x plus 1. So we want to know where is x 0, right? Sorry, where is y rather 0? Where y is equal to 0. So then you can solve this and say, well, this is where the general solution comes in. This is 2 tan x is equals to minus 1, and therefore tan of x would be minus 1 over 2, okay? And in this case, you can just say, well, this is at the arctan of minus 1 over 2, okay? So when I get that value there, arctan of negative 1 over 2, okay, I get 26.56, minus 26.56. Now, it means that x would be equal to minus 26.56, but remember we say plus 180k, where k is an element of integers. Now, let's find the exact point in this particular case, right? So if I say plus 180, so if I say k is equals to 1, okay? When I say k is equals to 1 there, so it means I'm substituting 1. So then I would have x is minus 26.56 plus 180 times 1, okay? So what's that value there? So I'm going to add 180 there. It's 153. So I get 153.43. So it means that value there is 153.43. Okay, let me write it in red. 153.43. It's that value over there, the red one. Okay, but you can do the same. I'm not going to substitute negative values for k. So another one would be where let's substitute 2 for k. So that's minus 26.56 plus 180 multiplied by 2. Okay, so I can say, all right, and I get a value of 333, right, 0.43. So 333.43. So in this case, our solution there, where x is actually cut through, that would be x is equal to, okay, let me write that in y, it makes it much better. X is equal to, so I do this, x would be equal to 153.43 and 333.43. Okay, and so those would be your solutions where the graph cuts through the x the x-axis, right? So ladies and gents, I think I want to kind of leave it there. Okay, hopefully it wasn't confusing. All right, so we will just leave graphs there and we'll look at past exam questions next time. Hopefully you are able to benefit and enjoy this lesson. All right, otherwise from me for now, I will see you guys next time. Please don't forget to subscribe. Please share and like our YouTube channel, and please just recommend it to as many people as you possibly can. Otherwise, I'll see you guys next time. Sharp, sharp.